So I want to show you what kind of question will be on the homework, right? Because word problem usually people finds it difficult, right? Or afraid to do it by themselves. Okay, so we can quickly go over the homework I'll be assigning, right? And see if you are okay, right? If you have any questions, right away we can solve it, then you have no problem doing them. So like on page, right? You guys can turn to page 48. So number 7 is an area. 7 and 8 are both area, right? 7 is a rectangular border on one side by a stream, right? So that means you cannot have, you don't need a border, right, on the stream. And on the other side, by 600-meter of fencing. Okay, so that question is similar to the one I mentioned here. It will be the second type, right? One side you have a river, right? The river on one side. So you don't need a fence. You only have fence on 3 sides. And the 3 sides, they add up to 600, right? So you can choose either the length to be x, right? Or you can choose this one to be the x. It doesn't matter, okay? And then same thing, you do the length and width and the area, okay? So let's take a look at that again, right? So the area has to be maximum, determine the area. So this one is looking for area, not the dimension, okay? But of course you need to know the dimension as well, get the vertex. And number 8 is also about fencing, right? It has 80 meters of fencing. And this one, it did not say any tricky part. This one is just a regular rectangle, right? It didn't say one side is on the stream, right? This one is a rectangle with one side, you don't need the fence. Okay. Number 9 is a review of finding two numbers. So that one is a very simple one. Number 10 is also area. Okay. Same thing here. It says only 3 sides must be fenced. Okay, because there's a rock wall. Okay. Now for 11 and 13, sorry, 11, right, and 14, those are the two questions with the revenue. Okay, so for number 11, you have $80 if there are 30 people, right, on the bus. But if there are more than 30 people, right, in excess of 30, that means more than 30 people, then you will start to decrease the price, right? Because you get more people coming in, right? So I can drop the price to save you guys money, right? So decrease $2 per person for every one extra person, right? So which means if it's if they drop the price to $78, then you have 29 people coming in. Okay, so this is the number of steps. So the cost will be dropping for this one, right? Instead of increasing, right? When you are when we were doing the amusement park, we were adding the cost on, right? But this one will be, sorry, I made a mistake, right? Will be 31 people, right? Because it's cheaper, right? So we're dropping the price at the same time the number of people increases. Any question on 11? Can you raise your hand if you understand here? Okay, so this is similar to the amusement park, except it's opposite, right? Instead of adding on the price, we are decreasing the price. So when you are doing the last statement, you will be doing the opposite as well, okay? So you set up the chart like that. Number of steps is still X, okay? Let's look at 14. 13 is also area, okay? So here it mentioned the no rope is needed on the shoreline. So same thing, this one is also like a rectangle, right? Here's the shore, okay? Number 14 is membership, right? Student wish to use computer lab, right? Must buy a membership. So the library charges $20, right, for if 400 people buys them. Okay, now if they increase the price by $4, then 40 fewer students will come. Okay, so similar. Okay, instead of $2, we have $4. Okay, so you do the same thing for the last statement, similar. Okay, and then get the vertex and answer the question. So this one is asking for what's the membership fee. Okay, so what's the cost? Anyone has questions about these word problem? So how many are there? 7, right? 7 word problems. Okay, so we'll see how you guys do on the homework, right? So I want to start a new chapter now, okay? So the new chapter is called the Quadratic Equation. Compared to function, function is all about graphing, right? Everything is about APQ, get the vertex, axis symmetry, right? But there's a connection between equation and function. So does anyone remember, I think at the beginning I compare equation and function. Does anyone remember what's the difference? Equation and function. Anyone? It will be very difficult, right? Because I mentioned it in the first class. Does anyone remember what's the difference between function and equation? Yeah.
Equations looking for the x-intercepts, right?
Very good. And the function?
The function is you could graph the points like x and y.
Yes, excellent. Okay, so let's look back. Maybe I wrote it on top. Okay, yeah, I did. Right, so function, right, this is very first page 32, right, the beginning of function. Function is we can graph points because you have x and y. And equation is you look for x-intercepts. Okay, so that's our focus now. We're looking for x-intercept on the graph. So what I would like you guys to do for these 3 graphs is to get their x-intercept. Okay, but before that, let's fill in some blank. Okay, so if I give you a quadratic function, right? So this one is a function, right? Because you see a y there. If I replace the y with 0, right? So this one becomes 0. Okay, so let me, yeah. So y now becomes 0. Then this new equation is called the quadratic equation. Okay, so when we solve for x, that means you're looking for the x value that can make y equal to 0. And when y equal to 0, that's the same as finding x-intercept, right? X-intercept means there are points on the x-axis. And those points, they all have y value of 0, okay? So the value of x that satisfy the equation are called the x-intercept. Okay, that's if it's on the graph, we call them x-intercepts. They are also the value that makes the y 0, right? So they are also called the zeros. Okay, or we could call them the roots. All right, so this chart down here, it connects the function with the equation. Okay, so the left side is the function, right? This is the function, and with the function we can get a graph, right? Once you have the graph, then you can use the graph to tell the x-intercepts, right? X-intercept are also called the roots. So roots, this side is the equation part, okay? So this explains the connection between 2 worlds, right? So please change each one of them, okay, into the vertex form, and then we'll make a graph, okay? So we'll do all 3 at the same time. Okay, I'll go over the first one, okay, together, and then you can do number 2 and 3 on your own. So factor A, right, 1 take out. divide by 2, so plus 1 squared, balance 1 minus 1 squared times 1 that you take out, minus 3 you put it at the back, right? Everyone should be familiar with this now. And then the standard form will be x minus, right, because minus 2x, 1 squared, and this will give you minus 4. So that gives us a vertex of 1 and negative 4. Because this one has a 1, right, at the front, so we could use a quick way to graph it, right? Instead of table of value, vertex at 1, negative 4, so that's down here, right? And then for if the A is 1, then it just goes up 1, right? And then up 4. If you remember the second method, like this, okay? Only for 1 though, okay? So you get 5 points. Or you could use table of value, that also work. Okay, up 1, there's 1 step, and up 4. Okay, when A equal to 1, then it will always go like this way. This one opens up. So based on this, we can see the x-intercepts. These are the x-intercepts, right? Where the graph crosses the x-axis. So we have x equals to 3, and the other one is negative 1. So these are the roots. We have 2 roots. Okay? Any questions so far? So I'm gonna let you guys to finish number 2 and 3, okay, by yourself. When you finished, you can raise your hand, okay? So do both the vertex, get the vertex, okay, and the graph and the roots, okay? So x equal, okay? Same setup. Okay, let me know if you get any of you have questions, okay? How to do the graph or the roots. Should be okay. Okay, I think by now you should at least finish number 2. Okay, so can I have Eric? What's your vertex form for number 2?
1, 0.
Vertex at 1, 0. Okay, can you tell me the form, standard form?
Y equals 1 times x minus 1 squared.
That's it?
Oh, Oh, that's the general, I think. The standard then is 1 times x squared minus 2x plus 1 minus 2 squared times 1 plus 1.
Okay. So that's the steps, right? Okay, so this is the form. Okay, let me write it down. Okay, this one is the general. Okay, I think you got the name mixed up. X squared minus 2x plus 1 squared minus 1 squared plus 1. X minus 1 squared. Okay, so the graph, right? So this one has a vertex of 1, like that. And then because A is 1, so it's same kind of expansion, right? Vertical expand. There's no vertical expand. So this is a regular one. Okay, so Nathan, what's the root here?
It should just be 1.
Yep, x equal to 1. Okay, so we have only one root or only 1 0. Okay, roots, zeros, x-intercept, they all mean the same thing. Okay, x-intercept means the in the graph, we call them x-intercept. But when we are in equation, we call them the zeros or the roots. Okay, zeros because they make the y become 0. And they are called the roots. Okay, you can think of it, that's the places where the it hits the x-axis, right? So it's kind of on the ground, right? X-axis is on the ground, so those are the roots, the root of the graph, like the tree root. Okay, what I mean is that, so coming off, right, coming out of the ground, that's where it starts. Okay, so we call them the roots. Okay, if you finish number 3 as well, please raise your hand. Okay, Brennan and Eric, have you finished number 3 too?
Not yet.
Okay. Okay, Colin, can you tell us your standard form?
1 bracket x plus 1 square plus 1.
Plus 1, okay. And the vertex, Eric?
1 plus 1 and 1.
Do you have the same standard form as Colin? Eric, do you have the same?
Yeah. Oh, I mean minus 1 and 1.
Okay, -1. All right, so be careful with the p, right? Value of p, you need to flip the sign, right? A and q is whatever you see, right? So we have vertex at -1, 1. So that's right there. This one is a regular parabola. Okay, so Yosher, what's the root?
None.
Yeah, very good. Okay, so this one is none. Okay, there are no roots. Okay, no roots. So these are the 3 possibilities, right? Sometimes you get only one root, one answer, right? Sometimes you get 2 answers, sometimes you get even no answer, right? So later on we'll spend more time talking about how can we tell how many roots we get. All right, so let's look inside this chapter. Okay, what are the topics that we're gonna cover? Okay, so there are different ways to find the roots. Of course, one of the way we just did it, right? You need to graph it to see it. You can find the roots by graphing, right? Or if you don't have time to do the graph, or they are too difficult to graph, we have different ways. So the first method is called the GCF. Okay, you can highlight that, right? Factor by GCF. Second way is the cross factor. or just factoring, okay? And then third method is isolate variable, right? That's on the next page, right? Number 3. Number 4 is complete square. Number 5 is quadratic formula. So total 5 methods, okay? And then after you know how to find the roots, of course, there are applications, okay? Apply to word problem. And there's nature of roots, which is talking about how many roots there are, okay? Instead of finding them, we just try to see a pattern. Is there a way we can figure out how many roots there are? Okay, so that's the setup of the chapter, okay? Before we end the class, we're gonna cover first method because that's the easiest one. Next week, we can dig deeper, okay, into the chapter. So before we begin, okay, let's write down all the methods that we just talked about, right? First one is GCF, right? Easier reference, right? Every time we just look at this. Second one is cross factor. Okay. Number 3. Okay, what is number 3, Nathan?
Isolate variable.
Yep, very good. Isolate variable. Okay, and what is number 4, Aaron?
Complete squares.
Complete square. Yeah, that sounds familiar, right? Complete square. Okay, and then last one, Eric, what's number 5?
I forgot.
Take a look at your book.
I know. Okay.
Number 5. Found it yet?
Quadratic formula.
Yep, very good. Okay, quadratic formula. Okay, please do not mix up formula with equation. Okay, quadratic equation is a question. Quadratic formula is to help you find the roots. Okay, it's very easy to mix those two. So these are the 5 methods. Okay, 5 methods to find the roots. So today we're just gonna cover the first one. Okay, GCF stands for greatest common factor. So you will use it when there is GCF, right? Pretty straightforward. There is GCF. Okay, but before we begin, right? Before we do the question, first you need to understand a concept, okay? So let me put it on the side here. When you have two things multiplied together and you want to make it equal to 0, okay? Two things multiply equal to 0. What will be the two numbers that could work? Brennan, can you give me two numbers that multiply equal to 0?
Any number with 0.
Can you give me an example then? What times what?
Like 1 and 0.
1 times 0, yeah. Okay, so it could be 1 times 0. If I flip it over, it could also work, right? 0 times 1 could also equal to 0. So as long as one of the bracket equal to 0, then the equation will work, right? Will be true, all right? So that's the idea here. We need to break it into 2 brackets, multiply together, and then make either one of them 0. Okay, so this one can be anything. The first bracket can be anything. Second bracket can be anything, but the other bracket has to be 0. Okay, then the equation will be true. So turning to brackets, that's called factoring. So let's look at question 1a. Okay, so what's the common factor for the left side? What do they have in common? Sarah? What do they both have? Yeah, they both have x, okay? So we're going to factor the x out. Just like the way we factor a, right? We take out the x. Take out the x means you divide by x, right? So you will be left with What's the leftover then? Yoshir?
3x plus 5.
Yeah, very good. 3x plus 5. Right, so here you have two brackets that multiply equal to 0. So using the idea we have above, right? In order to make the equation true, you make either one of the brackets, okay? So you have two brackets here. You could have either the first bracket equal to 0, or the second bracket, right? That's the thing in the second bracket equal to 0. Well, the first one, the x is already by itself, so that's the answer, right? The second one, however, you need to isolate x, right? Solve for x. So you move the 5 over, right? Become -5. Okay, let me show the step, right? And then divide by 3 on both sides. Okay, so we get x equals -5 over 3. Okay, so we have two roots. Okay, so what this means is on the graph, okay, those are the two x-intercepts. You have one x-intercept is at 0. The other one is at -5 over 3. And this parabola, right, this is a parabola here, right, quadratic function. So this one opens up, right, because the 3 is positive. So it goes like that. Okay, that's if you want to see it from the picture. That's what it means, right? This one is the -5 over 3. This one is the 0. Okay, but then in this chapter, all we care about is just finding the x. You don't need to draw the graph, okay? You just find those two and then box them. All right, so that's the end of the zeros or the roots. So I'll let you try question B and C, okay? And then when you finish, you can raise your hand, okay? We'll check each of them. Okay, each of the question, you just try to factor, okay? And then solve each one. At the end, you write x equal to something, okay? You should get two answers. If you have any questions, you can ask me now, okay?
Jason, can I see the previous page again?
Well, you want to see previous page? This one?
Yeah. Oh, wait, never mind. I wrote it down.
Okay.
Thank you.
Yep, you're welcome. Please raise your hand if you found the roots for both questions. Okay, let's check question B first. So Colin, what did you factor out?
X,
And what's left?
X, bracket X, and then bracket 4 plus 3X.
4 plus 3x. Okay, very good. So we solve each one. So the first one, Aaron,
X is 0.
Yeah, and the second one?
X equals to -4/3.
Okay, very good. So 4 plus 3x equal to 0. You get x equals to -4/3. Okay, so at the end, you can make a conclusion like this. Okay, put it together. Okay, easier to find your answer, right, in your work. Any questions for this one? Nathan and Sarah, have you finished all the questions? Okay, so Yosher, what do you factor out for C?
T.
Okay, is that the biggest you can take out? Anything you can take out?
5.
Yes, okay, so GCF, right? Remember, it's greatest common factor. Both of them can be divided by 5 as well, so we take out 5. So what's left then? Yosher.
T minus 4.
Yeah, very good. Okay, so please remember to take out the greatest factor, okay, not just the T. All right, so Brennan, what are the two equations now?
5t is equal to 0.
Yeah, phi t equal to 0, then that can give you t equals
0.
0. Very good. Okay, and the second equation?
I'm still working on that right now.
Okay,
This is 4, right?
yeah, so t minus 4, that's the second bracket, right? Make it equal to 0. So t equals to 4. Okay, make sure this is how you can show the work, right? Showing the step. So please don't just write your final answer in the box, right? Show the steps that you know how to do the factoring, okay? And then at the end, you can put it together in the same box. Okay, so I think we just finished right on time. Okay, you guys did great. So the homework will be these word problem we went over, right? The red circle ones. And then I will choose some question with the quadratic equations, okay? So next week we can get right into the harder questions for the equation. So if you have any question, you can stay after class. Otherwise, have a good weekend. I'll see you next week. Okay? Goodbye, everyone.
Bye.
Bye, Nathan.
Bye.
Bye.
Okay, see you, Jason.
See
Bye.
you. Bye-bye.